Now another next topic is working rules of definite integration. That is, the first rule is if functions f and g are continuous on the closed interval ab, then a to b f of x plus g of x over the function x is equal to a to b f of x dx plus a to b g of x dx. So we have to prove this if we have to integrate and taking the limit a to b as a sum of two functions, then we can integrate the function individually and then taking the limit from a to b we will get the same result. We have to prove this result before we are going to apply in the problem. So the proof is let f of x is equal to derivative of small fx and g of x is equal to derivative of small gx be primitive of fx and gx. As fx and gx are the primitive of fx and small gx, then sum of capital Fx plus capital Gx be a primitive of small fx plus gx. Then according to fundamental principle of definite integration, we have a to b f of x plus gx over the variable x is equal to capital Fx plus capital Gx over the limit a to b. So we get upper limit minus lower limit. That is a to b fx plus gx over the variable x is equal to f of b minus f of a plus g of b minus g of a. So we get a to b f of x dx plus a to b g of x dx. So the next working rule is if f is continuous on closed interval ab and k is a constant, then a to b k time f of x dx is equal to k times a to b f of x dx. Now the solution is, that is proof. Let here first we will take capital F of x with the primitive of small f of x on closed interval ab, and k is any constant. So here we have to prove integration of product of constant with the function is equal to k times integration of the function over the limit a to b. So as k is any constant and fx the primitive of small fx, then k of f of x be the primitive of k of f of x. Then by fundamental principle of definite integration, we get a to b k f of x dx is equal to k times capital F of x dx, capital F of x, limit a to b. So as k is constant, it will be come out and we will take limit over the function f of x from a to b. So it becomes k into f of b minus f of a. That is, we can write it as k into a to b f of x dx by fundamental principle of integration. So these two were the working rule of definite integration. Now the next working rule of integration is, if function f is continuous on closed interval ab and a is less than c, c is less than b, then a to b f of x dx is equal to a to c f of x dx plus c to b f of x dx. That is, if a to b closed interval is subdivided into a to c and c to b, then integral is also divided from a to c and c to b, and their sum is also equal to the whole integral a to b f of x dx. Now the proof is, let capital F of x be a primitive of small f of x over closed interval a to b. Then by definition of fundamental principle of integration, we have a to b f of x dx is equal to f of x over the range a to b, that is f of b minus f of a. Also a to c f of x dx is equal to f of x over the range a to c, that is f of c minus f of a by fundamental principle of integration, and also c to b f of x dx is equal to f of x over the range c to b, that is f of b minus f of c. This is as number 1, this is as number 2. So, from 1 and 2, we have a to c f of x dx plus c to b f of x dx, that is f of c minus f of a plus f of b minus f of c, that is f of b minus f of a, that is a to b f of x dx. Then we get, if a is from a to b and c is a value in between a to b, then we get a to b f of x dx integration is equal to integration of f of x dx from a to c plus c to b f of x dx. This result will be same as given by a to b f of x dx. So these were the three working rules to find the integration of definite integral, value of definite integral.